I'm Kevin, this is Francois, and we're going to talk a little bit about Selenium Grid 2.0 today. So first off, for those who aren't familiar with Selenium Grid, it's a component of the Selenium project. So last night at the keynote, Patrick was talking about Selenium as an umbrella for a series of different projects, and Grid is a component of this. A lot of people don't know this because unlike all the other Selenium projects, Grid is the only one that has not been rolled into the main project Subversion repository. So Grid has been off on its own GitHub repository, and it's been a goal to get that rolled back into the Subversion repository, so it's not this, ugly stepsister type project out there. But the goal of Grid really is to make it simple to maintain a cluster of Selenium nodes. Whereas a Selenium node is defined as a Selenium RC server or a WebDriver instantiation. And basically the goal here is to make it very simple to run a large number of tests in parallel against a well-known set of environments. An environment is basically defined as a browser in its version and the OS in its version. So with Grid, you register nodes and say they provide a particular environment. For instance, Internet Explorer 8 on Windows 7, Internet Explorer 8 on Windows XP, Internet Explorer 7. It basically gives you a finer level of granularity than you get with just the traditional browser string of like *I Explore, or even WebDriver's capabilities where you request Internet Explorer, but without jumping through a ton of hoops, there's no way to say, I want this particular version on this OS combination. So Grid makes it very simple to do all this. And it's basically broken up into three primary components. The focal point is the Selenium Grid Hub, which is the blue region you see in the upper right-hand corner here. All the clients connect directly to the hub, and that's where they request a browser session from. So if you're running hundreds of nodes, the clients don't need to know about all the different nodes, and you don't have to worry about dispatching requests yourself. The hub handles all that for you. The hub, in turn, communicates with the Selenium Grid node. The node is what provides the named environment. So when the client makes a request, it goes to the hub figures out what nodes are available, and it dispatches the request accordingly. A node basically is a lightweight proxy to either a Selenium RC server or a WebDriver instance. All right, so this is kind of the clunky part of the presentation. We've got two groups of people here, those that have never used Grid before and those that have used Grid 1.0. So if you've never used Grid before, this next 30 seconds is not going to make a ton of sense for you, but if I don't talk about this, the people using Grid 1.0 will kill me. So if you've used Grid 1.0 before, the previous block diagram introduced two things that are probably confusing you right now. The first and most important is Grid 2.0 now supports both the Selenium 1 and the Selenium 2 protocols, and you can mix and match those on a given host. This will allow you to migrate your existing Selenium 1 tests up to Selenium 2, and it'll also let you do things like if you already have custom launchers written using the older protocol, you can continue to use those while using some of the new stuff like the Android driver, which are WebDriver compatible only. The second major change is in Grid 1, there was a limitation where each node mapped directly to one RC server, which in turn mapped to exactly one browser. This created a really low limitation number of browsers you could run per machine. Basically, for each one, you needed to start up an RC server running anywhere between 256 to 512 megs of RAM. So for most machines, you weren't getting more than say half dozen browsers running on that. With Grid 2, that limitation's been removed, so now you can run as many browsers per machine as that machine can reasonably handle. This allows you to get a much higher density of browsers per machine, lowering the overall cost and administration overhead of maintaining your cluster. The next major change in Selenium Grid 2 was it's extensible now. So Francois actually wrote pretty much all of Grid 2 as a clean room implementation of Grid 1. He kept a lot of the good ideas from Grid 1, but over the past few years, there were limitations we knew about and didn't adequately address. So Francois' experience has been using Grid in a virtualized environment, primarily with VMware. Mine has been more of a cloud environment, particularly with AWS. And we recognize that beyond just managing a cluster of RC servers or WebDriver instances, a lot of the times you need to manage the actual machines too. So these hooks and listeners basically let you hook in at various points of the life cycle of a test. And you can do things like reboot a VMware image or roll back to a snapshot if for whatever reason a test locks up. Selenium Grid is now integrated into Trunk. It actually shipped initial version with 2.0 beta 3. It's really clunky to use at the moment, and we're actively working on that to make it something you can download and use in 2.0 beta 4. We've also focused quite a bit on usability this time around. So not only is Grid 1 off on its own as another project, but it bundles a rake file and it bundles an ant file. There's a launcher for the hub. There's a different one for each of the nodes. There's a ton of different command line arguments. There are YAML configuration files. For the most part, it's kind of a pain in the neck to get going with. This go around, we've packaged up Grid as a single jar that can function both as the hub and as the node. You just provide a command line switch, and that'll activate whatever functionality is necessary for that particular role. Baked into Grid out of the box is a set of resiliency features. So there are two very common situations that have come up. One is a node becomes unresponsive, either because of a network-related issue, or increasingly when you're in a virtualized environment or cloud, a node just disappears. This happens a lot on Amazon. Machine just goes away. And if that's still registered with the hub and it attempts to dispatch requests to it, you're going to see a high latency on those tests. So Grid has a built-in heartbeat protocol, which will basically constantly monitor each of the nodes that it thinks it has registered. And if for whatever reason one becomes flaky, we can execute one of these callbacks and let you take a corrective action. Out of the box, the default behavior is to just remove that node from the registered pool. The second half to that is clients themselves can be flaky. So if a client requests a browser session, whether that be a Selenium 1 browser session or it starts up a browser with WebDriver, and then that client crashes or loses its network connection, as far as the rest of the Grid is concerned, that machine has a registered test session and can no longer handle any additional work. And it won't handle additional work until the browser session is unregistered or otherwise closed. So we have some intelligence built in where we can detect that a session has basically been orphaned, usually because the client is no longer working with it, and we'll auto-unregister or close out the session at that point. And the other default out of the box behavior is the test processing order. So much like Grid 1.0, Grid 2.0 does FIFO test processing. So if you have, say, 2 Android devices registered on your node and you have 50 test requests come in, the first 2 will be dispatched immediately. The other 48 will queue up, and as resources are freed up, they'll get popped off one at a time in a first in, first out manner. All right, so at this point, Francois is going to wow you with a demo.
Yeah, so there are really 2 ways of using Grid 2. The first one is what Kevin just described. If you use the out-of-the-box version, you will not use all the advanced features, but the goal is to have WebDriver and Selenium legacy protocol supported, and everything from Grid 1 working exactly the same way. So that's the packaging. I don't know if you can read on the screen. That's the packaging of Grid 2. So you have one single jar that at the moment is called Grid Standalone, and you can pass a different number of parameters. So the first parameter and the most important is the type for the node or the hub. So you can pass either type equal hub, and that will launch the Selenium hub, or you can pass type equal RC, and that will launch a legacy the legacy Selenium 1 remote control, or a WebDriver node. So you've got the same kind of mechanism to monitor your grid. You go to the machine where your grid is, and you type /grid/console. So at the moment, it's not running. Now it does. So you will see that you've got an entry point for your grid. You've got no node registered to it yet, so you need to register the nodes. I will register one for WebDriver and one for the legacy protocol. Now that I refresh the page, I have the same kind of mechanism I had for grade 1, and I have a WebDriver proxy, a Selenium proxy. For the demo, I'm also going to run one in Windows VM. If I can switch to it. One in an Ubuntu VM. So you now have a grid with 4 different nodes. 3 are WebDriver, 1 on the Mac, 1 on Ubuntu, 1 on Windows, and 1 for the legacy protocol. So for some reason, it's taking some time on Ubuntu. So I'll start with the test that is not on Ubuntu. This one is showing a legacy test case with the default Selenium. So you point to your hub. You don't have to specify anything saying that it's on the legacy protocol. Grid will figure that out, and you run your test. When you run your test, you can monitor that on the hub. So you see that those 2 are used, and the tests are running. The tests are running. For the demo, there is a pause of 10 seconds so that you have the time to see everything. And I'll see if that now. So now that works on Ubuntu as well. So that's a test for Ubuntu. With WebDriver, you use the remote proxy the same way you would use it to access the direct WebDriver, and you specify what you want to do with the desired capability. So on this one, I want to specifically target the Ubuntu VM. So I specify platform Linux. You run the test, and you should see if everything works. So the Ubuntu VM running the test. Everything's passing, and I'll do a last test showing 6 Firefox this time without specifying the VM that I want. So I have some running on the Mac, so they will be used. I have some running on Windows, they will be used, and some running on Ubuntu. If you go back to the console, you can see that they are spread out against the node, and you've got your 6 test case running. Something that you see here that Kevin mentioned is that I launched only one node with the legacy protocol, but you have 5 browsers supported, so you don't have this limitation when you have to launch 1 remote control per browser. Okay, so 2 completely different use of the grid. One is the basic usage, and that's the one that I just presented. And so it's doing everything that grade 1 is doing, plus support for WebDriver protocol. And the other one is the advanced mode. The advanced mode has been done with virtualization in mind. I've been using Grid 1 for about a year, and this is working really fine for running the test. But what I also need is controlling not only the browser, but also the operating system around it. Sometimes IE or Firefox crashes, or I'm running out of memory, so I need to launch the browser, but also restart the virtual machine, etc. All those new features that you can do with Grid 2 are based on some listeners and hooks that you can implement, and you have two kind of hooks. One will allow you to change the behavior that Grid 1 is doing, and the other one is going to be around decreasing the maintenance time. That is mainly targeted to advanced users, because you need to understand how the internal of Grid is working, the web services and the API of your VM infrastructure, and you also need to know how to code in Java, because Grid 2 is in Java. The first set of listener that you can implement is around the customization of Grid. And if you don't specify anything, like I did in the demo, most of the interface are going to be null or will default to the default implementation, and that will always, except for one case, do what Grid 1 was doing. So if you install everything, don't change the configuration, you will have the exact same behavior as Grid 1. The capability matcher, and I think that was your question, is going to define how you direct the test case to your node. Every test case that's going to be run will specify what it needs to run through a map, the desired capability from WebDriver, and this is where you will specify, I want a Firefox on Linux, and I want an IE version 7 on Windows. By default, everything that you'll specify in there will be handled. So if you say Windows IE7, it will give a node that does at least that. But you may want to do more than that. If you want to have, for instance, IE7 or 8 or 9, you may want to modify the way you write your capability, your desired capability. And for Grid to know how to route that, you will implement the capability matcher. You can also imagine that you want geolocation. If you know that you have some VM in a specific country and you want to run the test there, you can specify that in your desired capability, and the Grid will route that to the proper node. If you don't specify anything, it will default to the Grid 1 behavior. The second interface that you can implement is the prioritizer. With Grid 1, you don't have that concept, so every test that you run is going to go to the Grid, and if the Grid is under heavy load, it's going to be first in, first out. That was a problem for me, because what happens sometimes is I have a user sending 1,000 tests on my Grid. I want to run 2 or 3 tests to validate something, and I have to wait for the huge test suite to be done. So you can bypass this problem with the prioritizer. What will happen is everything is going to go to the Grid, everything will be stored in a queue, and you can sort that queue. So you can say, I don't want to have a user having more than 50% of the resources, or if the test is coming from my continuous integration server, I want those tests to run first. Then you have the load balancer, and that's the only interface that if you don't specify anything, will not do exactly what Grid 1 was doing. In a Grid 1 world, when you register 5 remote on a machine and then 5 remote on the second machine, you will have a Grid that will have all the remotes sorted, and if you then ask for 5 tests to run, Grid will give you the first 5 remote that you have, so everything is going to go to the first machine, and the second machine will have no load, so that's not really what you want. What Grid does, it will sort everything by the number of test cases currently running, and it will spread the load between the different machines. So if you do the exact same example and launch 5 tests, you will have 3 running on the first machine and 2 on the second machine. The default implementation is working okay if all your VM have exactly the same size, but if you have plenty of different VM with different resources, you want to include that in your load balancer logic. If you have a very big VM with a huge CPU, you want to direct more tests there. So that's where you will put that logic. Those ones are less important, but that will make your life easier. So you can change the you can customize the web interface of your grid. I don't know if you've used grid 1 with more than 100 nodes, but if you do that, it will be very hard to understand what's going on, because it's too fine, it's too fine defined, and you have a huge list of 100 proxy, and you can't really do anything with it. So you can implement the HTML renderer, and that will show you what's running on a given proxy. So that's where you define all the icon and everything from the demo. What you would typically want to do with the HTML renderer is add more information. If you're using in a VM environment, you will put the CPU usage, the RAM usage, and all the debug information that you want. If that's not enough, you can use the custom servlet. So you will be able to register and create a completely new console from scratch, and you will put all the information that you want in there. So that's for one type of custom servlet. You have another type. When you register the custom servlet, because it's going to live in the grid context, it will have access to absolutely everything that the grid knows. Specifically, it will have access to the registry that knows what are the proxy currently running, and that knows how to add a new proxy. So what you can do, and that's what I'm using for my grid, is you can have a small web page with a form where you can specify what you want, what kind of node you want to register. So specify the timeout, the proxy that you want to use, all the interface that you want to implement. Do an API call to have the list of all the VM that you have in your network and deploy that automatically. So in the example showed on the slide, you see that you can create some nodes that support Firefox, IE, and Chrome, and deploy that on as many VM as you want. And when you click the submit button, everything is going to be done automatically, and the registration request will be sent to the node. So you don't have to remotely connect to your nodes anymore and launch everything from a command line. So that's for the first set of interfaces. The second set is more around maintenance reduction. So if you have a grid and you keep the grid for half an hour, that's fine. But if you want to keep the grid for 2 or 3 weeks and have a lot of node attached to it, you will always have something crashing, and you need to recover from that. So that's where you will use the maintenance reduction interfaces. The first one is the registration listener, and that's typically what you will use if you have the custom servlet that I've shown just before. So it will give you a chance to execute some script before the node is successfully registered. So you will send the registration request, but before the node is successfully added and the grid can forward some information to it, it will execute some steps. So typically in a VM environment, what the steps that you want to execute are find a VM, start the VM, revert it to a clean state, copy the latest version of Selenium jar, and launch it. You also want to make sure that you can ping the machine and that you can contact the JT server. When everything works, then only at that point you consider the registration successful, and you can start routing test cases to the node. The next interface is the self-healing proxy. That was inherited from Selenium 1. And the default implementation does what Kevin described. You will have a poll mechanism that will try to contact the node. And if the node is down for any reason, usually the network is down, it will mark down the proxy. So no further test is going to be assigned to it. It will keep polling, and when it's back up, the proxy will have some test assigned to it again. That's like the reactive healing proxy, but you can also add some proactive self-healing. So you can say, if every 100 test case, I want to restart my virtual machine. Or if the virtual machine is using more than 90% of the RAM, then restart the proxy automatically. So this one is not really, you can't really use it to do something on its own. So the only usage that I have for this one, if you just implement this one, you can ensure a clean state for the operating system. So you can imagine that if you want to test something very specific, you want to revert to a clean state where no tests have run, and run one test, and then take a snapshot to see what happens. The other usage for that is in combination with other proxies. With the self-healing, for instance, if you want to count how many test cases have run, you will use that. So in the test session listener, in the before and after method, you will increment counter to see how many test cases have run already. The timeout listener, again, is taken from the Green 1 implementation. What usually happens is, if you have a user starting a test from Eclipse, and in the middle of the test he stops Eclipse, you will end up in a grid that have received some start a new browser command, and they will never receive the stop command. So that listener will allow you to detect those timeout and send the complete test command. You can override that to do something more. You can say, if I have too much timeout or too many timeouts on a specific proxy, then wipe out the VM and restart a clean one. So that was for the description of the interfaces. Something else that's important to notice is that Grid 2 doesn't depend on Selenium. It depends on Selenium protocols, so it understands the legacy protocol and the new WebDriver protocol, but it doesn't have any dependencies to the Selenium internal itself. So if you have another automation technology that also speaks the WebDriver protocol, even if that's not web, you can plug that directly into the grid and leverage the virtual environment and everything. So to summarize, Grid 2 is doing everything that Grid 1 is capable of, but it also allows you to scale without increasing the maintenance cost too much. It's fully backward compatible, and it's not really advertised yet. So we are in Selenium beta 3. The code is there, but there is no documentation yet. That will be released with beta 4. That's the next release. So if you have any comment or requirement for the grid, that's the perfect time to send feedbacks. And that's it. So if you have any question.
So the question is, if you dynamically add a node, does it need to register itself? Is that correct? Yeah, so there are two ways of doing it. If you're trying to use the older Selenium 1 protocol, then yeah, you will need to start up the node. So it'll start up the RC server. The easiest way of doing that is just throw it in a startup.bat file, and when the machine comes up, it'll auto-register itself. Just use like a DNS name for the hub, and then just snapshot that for your virtual machine, so whenever you bring up a new one, it'll start up and just auto-register itself. If you're using the WebDriver protocol, you don't need to do that, and Francois actually alluded to this when he was showing the customized UI. So because you can add your own servlet, and it does have access to the set of registered nodes, you can do what he did, which is it basically polls the network, finds the list of all the machines, and he's able to control the registration of the browsers for that node through his own web UI straight from the hub. That answer everything? Okay, thanks.
Let me add something. So by default, it's not going to do what you want, either for WebDriver or Selenium 1. But if you're in a virtual environment, so I'm not sure for Amazon Cloud Computing, I'm mainly using VMware. What you can do is in your before registration listener, you will start your VM and you will revert to a clean state. You will copy the Selenium jar, and then you have an API. You have the VIX API for VMware that will allow you to start a command remotely on the node. So you can start the command there, but you can execute that from the grid hub. So in the grid hub, you will have access to everything. You already know the IP address of the hub, so you can start remotely the node, And you can do that if you have 200 nodes. You won't remotely connect to the 200 nodes. You will do that in a loop. So you don't really have to remotely connect to the nodes anymore. You can do it, and you can do a mix. So you can have some that you want to use to debug, and you will not implement the registration listener for those. And for the other one, you do everything else automatically. Yeah. Is it possible to launch multiple remote control on the same node? So it is possible, but I wouldn't do it. The reason for that is you can launch a single RC and have as many browsers as you want attached to it. And if you assume that you only have one RC or one WebDriver per operating system, then you can do plenty of cool stuff. And if you restart your VM, because your VM only have one proxy attached to it, you can be sure that when you restart, you're not impacting any other test. So when you want to restart your VM, what you will typically do is you will mark down your proxy so that no more test is assigned to it. You will wait for all the tests to finish, and only then you will restart it to make sure that you're not breaking somebody else's test. If you have multiple RC, you can't do that anymore because you have no idea what's going on in the RC next to you.
Sure. So the question was, could you use different ports for that? Yes, you can. What I think he was saying is if you register multiple RCs on different ports and one of them locks up, you can unregister that one, but if your corrective action is to reboot the machine, it will negatively impact the other ones that are running just fine. So you'd have to ensure that there's no browser session in use at that time. And it's doable, yes. It's the reason it would impact it is, say, on port 5000, you register Internet Explorer. On port 5001, you register Firefox. If Internet Explorer locks up, the only real way to recover from that in most cases is to reboot the machine. So if your automated corrective action is to reboot the machine, but Firefox is running fine, and it's in the middle of processing a test request, you're going to kill that test request prematurely. So what you'd have to do is go into a holding pattern, try to constantly monitor the browser sessions running on that machine, and then only reboot it when it hits a safe state. So all completely doable, but that's on you to ensure you don't mess that up. So again, the grid is not tied to Selenium at all. So if you can do it in Selenium, you can do it in grid. If you can't do it in Selenium, you can't do it in grid. So if you've got some crazy way of using a custom browser launcher that takes care of this for you, you're all set. If you use a browser launcher and then give it the additional argument string to set up the browser the way you want, all set. But if you're unable to do this, even just using WebDriver directly or through Selenium RC server, grid is not going to magically fix that for you.
So is there, have you experienced some problem with the hub if you have a lot of nodes? Are the performance degrading? What can happen is if you have a grid that is under heavy load, because the requests are going to be queued, and with WebDriver, the start new session request contains the Firefox profile in some instance, you're going to have a queue of very heavy objects, so you may run out of memory. I haven't experienced anything where just forwarding the request was a problem.